So, hello friends, welcome back to Code Explorer again. Here I am Pabitra Banerjee with you, and you are watching this video as a part of our Mastering DSA using Python playlist, and this is going to be our fourth video. In this video, we are going to discuss about operators in Python. So, in our previous video, we have already discussed about four types of operators in Python, which are arithmetic operators, relational operators, assignment operators, and logical operators. So if you have not seen that video yet, then go to the description box and link in the I button. There you will get the link of the video, and you should definitely watch that video after watching this video as well to get a better understanding of operators in Python. And if you're following the whole playlist, then you're welcome. So let's start our today's topic. So from today we are going to cover from these bitwise operators, membership operators, identity operators, shift operator, and arithmetical assignment operators, okay, which are also known as shorthand notations as well. So without any delay, so let's start the video. So what is bitwise operators? So picture this, that you have got a bunch of numbers and you want to play with their bits. What is bits? Basically bits means basically zeros and ones, which are binary. Okay, so that's where bitwise operators comes in, and we use them to manipulate these bits and turning them on or off basically. Okay, so we will learn about bitwise AND operator, bitwise OR operator, and bitwise XOR operator. Okay, they are like the magical ones of binary numbers basically. Okay, so we will discuss about them as we continue to this video. So there comes membership operators after that. So what's are membership operators? Think that if I wanted to check if something is inside a box or not. Okay, so well, membership operators do just that, but with Python sequences like lists or dictionaries or tuple and many more. And like, you can also use this for various data types as well, like string, character, or whatever data types you want. What is data types and what are lists, tuples, dictionaries, what are I am talking about? We will discuss about all of these data types in our next video, which will be our fifth video. Okay, so I will recommend you to subscribe this channel and also follow this playlist as well. So we will learn how to ask Python if something is inside a sequence or not inside a sequence using these membership operators, which is in and not in. Okay, there are only two membership operators. Then comes identity operators, which are basically is and is not. Imagine you have two boxes and you want to see if they are actually the same box or not. That's what identity operators do. They help us check if two objects are exactly the same or if they are different. We will explore is and is not and see how they can help us understand our code better. Okay, now move to shift operator. Shift operators are like moving bits around in a number. Basically, all of these shift operators are in a bitwise operators as well, but we have made this another segment to give you a better understanding of these operators. Okay, so we can shift them to the left or to the right using this left shift operator or using this right shift operator. Okay, these operators are pretty cool. We will see how they are used for things like data comparison and encryption. Okay, now we have arithmetic assignment operator, which is also shorthand notation. These are not operators in Python basically. They are combination of operators using these arithmetical operators and using these assignment operators. So we will discuss about all of them. We will learn about all of them when we will write code, and at that time I will discuss that what they are basically. Okay, so tie your seat and let's dive into the world of advanced Python operators together. By the end of this video, you will feel like a Python wizard ready to tackle any coding challenge that comes your way. Okay, alright. Let's dive into the world of bitwise operators, which are and bitwise OR and bitwise XOR operators basically. These little symbols might seem mysterious at first, but once you understand them, you will unlock a whole new level of coding magic. So come to this. Here we have our bitwise operators. I have not written about them here. So first I will show you an image, which is this. This is basically a truth table. I have collected it from Google. So what does this truth table means? If you have already a college student from science background, then I think that you have already read this in your school curriculum or college curriculum in physics basically. Okay, in networking segment where logic gates comes in. Okay, so here we have OR operator, AND operator, XOR operator. We have NOR, NAND, NOT. These are basically logic gates, and these are the logical operators as well. These OR operators, this OR operator basically denotes the logical our bitwise OR operator. This AND gate represents the bitwise AND operator, and this XOR operator represents the bitwise XOR operator. And we have these operators as well, but they are not commonly usable for now, so we are going to eliminate this for now. For now we will only discuss about all of these three. So first up, let's talk about the AND operator. Okay, imagine you have two numbers and you want to compare their binary representations. That's where the AND operator comes in. It's look at each pair of bits in the numbers and only gives you a 1, which is true for our case if both bits are 1. Otherwise it gives you a 0. Think of it like a gatekeeper. It only lets things through if they are both true. That means here you can see in the truth table that we have two inputs, which is one A and B. Then it goes inside this AND gate. That means when these all of these input have two value maybe, which is 0 or 1. 0 represents bit is off and 1 represents bit is on. At that case you can understand like that when we have 0 for A and 0 for B, that means both gates are off. At that time our output comes 0 as well. Okay, then we have, let's suppose our A is giving us 1, which is that means A gate is on, but B gate is giving 0, that means B gate is off. At that case also we will get 0. Then you can think like that we have the A gate off and B gate on. That case A is 0 and B is 1. At that case we are also getting 0. And let's suppose that A and B both are on. At that case all of them are representing 1. So A comes 1, B comes 1. So our output will be 1 as well. So you can think this like basically our multiplication types of things, like 0 into 0 comes 0, 1 into 0 comes 0, 0 into 1 comes 0, 1 into 1 comes 1. You can think this like that. Okay, this is not too much difficult thing, so I think you can understand this. Okay, so next we have our bitwise OR operator. This one's a bit more relaxed. It looks at each pair of bits and gives you a 1 if at least one of these bits is 1. Let's like throwing a party. As long as one person shows up, the party is on. Okay, that means here also comes the same. A and B, we have these two input and Q is the output. At that case it is going through an OR gate. Okay, so at that case when A is 0, B is 0, it returns as 0. But when A is 1 but B is 0, at that case OR gate will return as 1. When B is 1 and A is 0, at that case it will also return as 1. And at that case of A and B both input are 1, at that case it will also return as 1. So in this case you can understand this like that, like our addition, where 0 plus 0 gives 0, 0 plus 1 gives 1, 1 plus 0 gives 1, and 1 plus 1 gives us 2, but you can think like this is not 0, that means 1 here. Okay, so you can understand this OR operator like plus symbol and this AND operator like multiplication symbol. Okay, and we have this XOR operator. This is once a bit trickier. It stands for exclusive OR, XOR, which is exclusive OR. It gives you a 1 if the bits are different and a 0 if they are the same. It's like having a secret handshake. If you both do the same thing, it's not very secret. But if you do something different, it's sign a it's a sign of recognition. Okay. So here you can think like that, when the both inputs are 0, at that case we are also getting 0. At the case of both inputs are 1, which are also same, we are getting 0. But when comes different, like 0 for A, 1 for B, at this case the inputs are different, so we are getting 1 from this XOR. And when 1 A is 1 and B is 0, at that case we are also getting 1. Okay, that's mean you have to keep in mind that XOR operators basically return us the value 1 when the two inputs are different, and returns us 0 when the two inputs are same. Okay, I will discuss about these all when we will write code for this, so don't need to fear about this right now. We were going to discuss about this when we will write code. So why do we care about bitwise operators? Well, they are super useful for things like manipulating binary data, working with flags or permissions, and even optimizing code for performance. And even optimizing, they let us go deep dive into our code and some really cool stuff that you just can't do this with regular mathematical operations. But remember, bitwise operations can be a bit tricky to wrap your head around it first, so take your time and play around with them in your code. Once you get the hang of them, you will wonder how you ever lived without them. Okay, alright guys, now let's discuss about our membership operators, which are these in or not in. Okay, so the membership operators in Python are used to validate whether a value is found within a sequence, such as strings, lists, or tuples, or dictionaries as well. Okay, so here I have written this, that in operators description, what is return true if value exists in the sequence, otherwise it returns as false. Okay, not in operators do the reverse things, that means it return true if value does not exist in the sequence, otherwise it returns false. Okay, imagine you have a list of items and you want to check if a particular item is present in that list. That's where membership operators come in handy. The in operator checks if an element is present in a sequence, while the not in operator checks if it is not present. These operators are like your trustly search assignments, helping you navigate through your data with ease. I think you have got this. We will discuss about them when we will write code for them. Then here comes our identity operators. Identity operators in Python compare the memory locations of two objects. Here we have two operators, is and is not. Is operator returns true if two variables point the same object or value. Otherwise it returns false, and is not does the opposite things. That means it returns true if two variables point the different object or value, otherwise it returns false. Now let's talk about identity. These operators are used to compare the memory locations of two objects. These operators returns true if both variables point to the same object in memory, while the is not operator returns true if they point to different objects. Okay, as I have already told you, what that mean? It's like asking Python, are these two things really the same or are they different? These operators are particularly useful when you want to compare objects for identity rather than just their values. Okay, So now let's come to our, we will discuss about all of them, and I will share this PDF with you shortly in this description box of this video, and also I will share in the description box of this previous video as well. I have not defined with the left shift and right shift operators. Okay, here we have shift operators as well, so I will discuss about the shift operators when we will write codes there. Okay, and now we have these arithmetical assignment operators, and we will discuss about them when we will write code. So now move to our VS Code to practically see that how all of these operators works basically. Okay, so here I have came to my VS Code, and here I have already created operators2.py file, and here we will write codes for our. So first of all we are going to discuss about bitwise operators. Okay, for doing that I will simply create two variables. Okay, first I want to increase the font size here. Okay, I think it's perfect, and let's, this is bitwise operators, not bywise, this bitwise. Okay, now we are going to print this first. Bitwise operators. Okay, now let me create two variables. First one is 10, and let's suppose b, which is 20. Okay, for now I am going to create 8. Okay, now what we will do, now first of all I am going to check the binary representation of these two variables. Okay, so for doing that, we in Python we don't just need to write a lots of code like we have to write in C or C++ or Java like language, but here we have to use this print statement first, print function first, and then we will use this bin function, which is bin, and here we are going to this bin A, and then we are going to create for bin B. Okay, now let's print this using this code runner extension, and here we will get the binary representation of these two values. Okay, so here you can claim that we have for A, that's mean for 10 we have this 0B1010, and for 8 we have this 0B1000. For now here you have to understand that for this binary function we, this 0B comes default, so the binary value of our 10 is, so let me write that in comment, that A, which is our 10 in binary decimal, is equivalent to 1010, and for our B variable, which is 8, the value of its binary representation is 1000. Okay, I think you got that point. Now we will perform our bitwise operators here. We will try them. Okay, so first we have the bitwise AND operator. So we are going to simply print, we are going to simply print the A and B. Okay, so let's run this file again. Here you can see that it comes 8. That means here comes this 8. So here you can get that the answer is 8. So we have to first check that for AND operation if we get 8 or not. So here we will write another comment that will be A and B. That means here you can see that for the binary AND operation we have to just simply multiply the values. You can, I have already told you like that. For 00 here we have, okay, for 00 we have 0 into 0 means 0. Okay, now 1 into 0 means also 0. Now 0 into 0 means also 0, and 1 into 1 means come 1. That means for this binary AND operations between A and B, which is 10 and 8, we are getting 1000, which already represents this B. You can see this. Okay, so for that reason this A and B is printing this. Okay, so we will just try to print the binary of them as it. So we are going to use this binary of function which is bin, and then we will reprint this. Here you can see that it is coming 0 1 0B 1000. That means our code is working perfectly. Okay, and I think you have already got understood that how our AND operations works. Now we are going to use this same for our bitwise OR and bitwise XOR operator. So we don't know the answers right now, so we are going to leaving it's empty, and this will be our binary OR operator, and this will be our binary XOR operator. Okay, now let me tell you that how we can calculate them. That means how Python will calculate them basically. So A or B is equal to, how will it be calculated? So calculate from this left side. Now, as I have already told you that for OR operation you can think this it's like plus symbol. So 1 plus 1, which is 2, that's when it's not 0, so we can write it like 1. Okay, 0 plus 0, that is 0, 1 plus 0, 1, and this 0 plus 0 comes 0. Okay, and now we have to print the XOR operator using this XOR operator. Okay, so as you can see that these 1 and 1 are the same inputs, so XOR operator will give us 0 for that. 0 and 0 are also same input, so XOR operator will give us 0 for that. Now you can see that 1 and 0, that's mean for that case it's different inputs, so XOR operator will give us 1 for that, and 0 and 0 are the same input, so XOR operator will give us 0 for that. Okay, so what is the binary representation of 100, which was 8, and for 1010, which is our decimal representation, is 10, and for binary 10, decimal representation is 2. So let us check that if we are getting this same output or not. Okay, so let's run this code. Here you can see that we are getting 8 for the first AND operation, then we are getting 10, which is 1010, we are getting 10 1010, and then for the XOR operation we are getting 2, which is binary 10. And you can see that we have made all the correct calculation correctly. So I think now you have understood that how basically bitwise operator works. Okay, so I will share this code with you in the description box. You can check this out. Now we will discuss about membership operators. Okay, so membership operators. So first I am going to print these, that the code doesn't messed up. So membership operators. So what is membership operators basically means, as I have already told you that for Python we need to check that if one thing is present inside that string or dictionary or tuple or set types of data types or not. So for that we will use in and not in operators. Okay, so first let me create two different variables. So I have already created A and B, so now I am creating C, and inside that we are going to write hello world, let's suppose. Okay, now we will check. What will we check? Print let's suppose I am going to check H in C. For now I am going to say you that we will getting a false here. Why we will getting false? You will say that H is inside this C statement, but why we will getting H? But here you can see that we have this capital H, but I have written small h. Okay, so for that reason we are going to get a false. So let me run this first. Here you can check that we are getting false because all the characters in Python are basically case sensitive, so you have to keep in mind that. Okay, so now we are going to print the same. So we have this H here. Now the output will be true for this statement. Here you can check that we have this true. So what is string basically? So let me tell you first that when we declare something inside these two inverted comma, Pythons create a string for data type for that. And when we tries to check that one element is inside a string, so at that time we have, when we will use these membership operators, at that time we have to use this single quotations for to declare strings. Here this is H is a string. Okay, so we are checking that this H substring is present inside this main string or not. Okay, so if I write that H is inside or not, so for that I am going to write not in operators. Okay, sorry, not in operators I am going to use. So here you will get true, and if we print this using this not, we were going to get false. So let's run this. Here you can see that small h is not present inside this C string. That means it's returning us true. H is inside, capital H is inside the string, so it's returning us true as well. But capital H is inside that string, that means the not in statement is false. At that case, it is returning as false. Okay, I think you have understood this. Now we are going to discuss about identity operators. Identity operators. So I am going to print identity operators. So what types of operators we have here? We have is and is not operator here. Okay, we will check that if the two elements are same or not. So for that I am going to create two more variables for that. So one is d. Let's suppose d is 30, and let's suppose e, which is 40. Let's suppose I am creating another variable which is 30 again. Okay, so now we are going to print. So I am going to print that if d is e. Okay, now I am going to check that if d is f. Okay, so let's run this code now. Here you can check that d is e as returning as false, because d is not e, that means 30 is not 40, that's why it is returning as false. But when it comes that d is equal to f, d is f, that means 30 equals to 30, at this case it is returning as true, and the vice versa will happen. So let me show you that. We are going to check that print d is not e and d is not f. Okay, so let's run this. For that reason, here the first case is returning as false, and it's also returning as true, because obviously d is not e, that means obviously 30 is not 40, that's why it is returning as true. Then we are saying that 30 is equals to 30, that's why it's also true. and then it comes that D is F, that means 30 is equal to 30 is not equal to 30, it's false, so it is returning as false. Okay, I think you have understood that what are basically our identity operators. Now we are going to discuss about shift operators in Python. These operators represented by the right shift operator and left shift operator allow us to shift the bits of a number to the left or right respectively. Sounds a bit technical, right? Don't worry, I will break it down for you in simple terms. So for now I am going to write here in comment that shift operators. Basically shift operators are also comes inside the bitwise operators as well, but we are dividing these into parts to give you a better understanding. So shift operators. Okay, here is a quick breakdown. First listen that. What is left shift operator? When we perform a left shift operation, what is left shift operator first? So I am going to show you that what is our left shift operator. Our left shift operator basically seems like this, and the same happens for these also. So I am going to write shift operator, which is our this. Okay, I think you got this. So when we perform a left shift operation on a number, we move all its bits to the left by a certain number of positions. Each bit is shifted to the left and new bits are filled in from the right with zeros. It's like moving all the digits of number to the left and adding zeros to the right. Okay, so how it basically works? So let's check. For right left shift operator, we are going to say I am going to declare another variable, so I have declared till f. So you have g. Let's suppose g is 10. Let's suppose g is 10, which is binary representation. So the binary representation of 10 we have already done that, which is 1010. So I am going to write the binary here. Using the binary operator, we can get the binary of g will 1010. Okay, so now what will we do? We are going to shift this. Okay, so how we can shift that? So we are going to create another variable for that. So h will contain the g with left shift with position 2. Okay, now we are going to print h, and we are also going to print the binary of h. Now you will understand. So run this. Here you can see that for 10 we are getting 40 as our left shift operation when we perform the left shift operation for 2. So here you can see that the binary is 101000. So let me copy this and I will paste this here. Okay, so the 40 which is equals to 101000. How is the difference? What is the difference? You can see that this 20 has been added to the right side. That means the whole number is shifted left and the 20 has been filled to the right. This is the works of left shift operation. The similar happens for the right shift operation as well. So I am going to just simply write the code. So now I am using I. So let's suppose I is also 10, and for now we are going to use right shift operator. So let's suppose j will help as for that, so write shift operator using 2. We want 2 shifts, and then we are going to print this as well. Okay, so we are going to print not I, we are going to print J. Okay, we are going to print J. Now run this. Here you can see that we are getting 2, which is 1 0. We are getting 2, which is 1 0 only, and the 10, that means it is, let me write the binary of this. Binary of I is 1 0 1 0. Okay, now let's understand that what's basically our right shift operator do. So when we perform a right shift operation, we move all the bits of a number to the right by certain number of positions. For here we are using 2, that's mean it's returning us, it's deleting these 2 part, it's shifting this to the right. Okay, now new bits are filled in from the left. If the number is positive, zeros are added to the left. If the number is negative, ones are added to the left. This is the rule, simple basic rule of left shift and right shift operators. Okay, I will share all of these codes with you inside the description box. From there you can definitely check that. In the above code, we first use the left shift operator to shift the bits of the number 10 to the left by 2 position. This effectively multiplies these 2 positions, and then the number by 2 raised to the power of the shift count 2 in this case, resulting in 40. Then we use the right shift operator to shift the bits of the power number 10 to the right shift by 2 position, resulting as 2. Shift operators might seem a bit abstract at first, but they're indisputably useful for tasks like binary manipulation, encryption, and optimization. So experiment with them in your code and see how they can add a new dimension to your programming skills. I will recommend you to write your own codes. Okay, I will recommend you to play with your codes. This will give you a clear understanding of programming. Now we are going to talk about our this topic, which is arithmetic assignment operators. Okay, now we are going to discuss about this. As I have already told you that these arithmetic assignment operators are not like that. It's basically the combination of 2 operators, which is arithmetic operators and assignment operators as well. Okay, so let me tell this to you using the codes. For here we are going to use, let's suppose k is the new variable, so let's suppose k is 25, and let's suppose L, which is 10. Now we are going to perform some specific types of tasks. So for now we are going to print the value of k plus L. Okay, you will say that what that means. That means it's simple, 35. Obviously it is 35. Here I have written that it's add 2 numbers and assign the result to the left opponent. What if that we want to increase the value of A using this B? At that time we will use this. So for now we are going to use that k will be plus or equals to L. Where has this gone? Okay, we have to declare this at first. So as a k l m, let's suppose m is equal to, sorry, k is equal to k plus L. For that we are going to print this k. What if we will print this k now? It will give us 35 now. Okay, because the value of k is now 35. I think you have got this. Now what if that we want to print that k is minus equals 12, and we are going to print the value of here, and then we will perform this, and then we will perform that. Here you can see that the value of L is k is 25 now. Okay, because when this comes, that means 35 minus 10, which is 25, it prints the value of k like here. Then it comes like, let's suppose you can think k multiplies equals to L. At that case, what will happen? Let's check. It will print 250 because now k is 25 and L is 20. L is 10. At that case, 25 into 10, which is 250, is printing. Now we have divide equals to L, and then we are going to print. So here you will get 25 again. Okay, we are getting 25, but in decimal format. We will discuss about them when we will read about data types. Okay, so you don't need to fear about this right now. Now we have three more operators in arithmetics. So we are going to use, let's suppose, modulus operator. Modulus operator is L. Then we are going to print this. Here you can think that we are getting 5. That means when we divide 25 by 10, the remainder remains 5. Okay, now we can use that k is floor divisible by L. Floor divisible or equals to L, and then we are going to print the k value of k. At that case, it returning as 0 because when we comes here that the value of k remains 5 here, and 5 divided by 2 is 0.5, and when it is rounded up this, it prints as 0. Okay, and one more thing we have. Okay, so let me print that here using two. I am using this m. Let's suppose it is 7, and let's suppose n, which is 2, and now I am going to print I am going to not going to print like that. Let's suppose O is another variable, which is m. No, I'm not going to discuss about that. M exponentially equals to n, and then we are going to print the m. Okay, now run this code. Here we are getting 49. Now the value of m is 49. And now what if we print these values again? What if we does the same task? At that case, it will increase. No, not print k, it will print m. Okay, in that case, the value of m will be increases, like 49 to the power. At that case, it is 2401. Okay, we are increasing this like that. When we need to assign the value of the left operand by performing any other task to the operand, then we can use this arithmetic assignment operators. Okay, these are our shorthand operations. We are going to use these widely, so you need to understand them and you need to play with them first, thus you can understand them. Okay, so I am going to share all this code with you in the description box, and you can simply check this out, and I will recommend you to write your own code, thus you can get better understanding of the program. Okay, so that's it for today's video. We are going to discuss about data types in Python in our next video. Till then, stay safe, and if you have not subscribed this channel yet, then please hit the red button and please subscribe this channel. And if this playlist is helping you to learn Python and will help you to learn data structures and algorithms using Python in future, then don't forget to share these with your friends as well. And you can also leave a comment for me that how we can improve, what do you want to learn, what your problem you are facing, and if you want to give me any suggestions then you are also welcome. Okay, so I will see you in the next video with the data types of Python. Till then, stay safe and happy coding.